Okay, my dear children. So, in this chapter, we'll discuss several more questions, right? Several other questions related to our lesson. So, starting from 21st MCQ onwards, we'll discuss the questions in this part. Okay, so question number 21. Ash, cert is created due to, right? Ash, cert is created due to. Cert means if you take that black color substance created during a combustion, that is called as cert, right? Black color substance which is created during a combustion of a certain fuel. Especially if you take firewood, cert is getting created, right? The black color leftover residue is called the cert, right? So ash and cert is getting created due to incomplete combustion of the substances. So incomplete combustion is the main reason for the creation of cert plus ash, right? So my dear children, let's see what are our responses. Ash and cert is created due to complete combustion. No. If it is a complete combustion, we can't observe these things. In a complete combustion, the only products which are getting created is carbon dioxide gas plus water vapor. That's it. Number 2, incomplete combustion. Incomplete combustion is the answer then. Due to incomplete combustion, several other products rather than the water vapor and carbon dioxide gas is getting created, like ash and cert, right? So ash and cert, all of these things are unburned carbon particles, made up with unburned carbon particles. If there is nothing to burn, right? If there is no substance to burn up with, right, there won't be any residue. So cert and ash, those are leftovers from a combustion. So those things are made with specially from carbon particles. So unburned carbon particles are the main reason for the creation of cert plus ash. Okay, so incomplete combustion is our answer. Ash and cert is created due to incomplete combustion. So due to having more oxygen, if it has more oxygen, right, if it has more oxygen, in that kind of a situation, we can observe, right, we could see a complete combustion. If there is plenty of oxygen, then complete combustion could be observed, right? So it's also incorrect. Due to having less amount of carbon, that is also irrelevant with the question actually, right? There's nothing with this response which is going to correctly respond with the question given here. So carbon is not going to give out a direct impact on the combustion process. However, right, this fuel is mainly made up with carbon, okay, but the amount of carbon is neglectable, right? Amount of carbon is not necessary for the complete combustion and for the incomplete combustion process. Okay, only thing that is relevant is the oxygen gas. So if there is plenty of oxygen gas, there's going to be a complete combustion. So our answer would be incomplete combustion. Name given for the state change from solid to gas. Solid directly getting converted into gas. Solid is directly getting converted into gas. So solid is directly getting converted into gas when you are going to heat iodine crystals. So that process is referred as sublimation, right? So converting a solid directly into a gas is referred as sublimation, right? So my dear children, sublimation is the answer. Fusion is converting a solid into a liquid. Fusion means converting a solid into a liquid. Vaporization means converting liquid into a gas, right? Deposition means reverse of this process, gas into a solid. Okay. Type of reaction when adding sodium hydroxide with lime juice. Type of reaction when adding sodium hydroxide with lime juice. Sodium hydroxide. I told you that if there is hydroxide, then it is a base. Lime juice. Lime juice, you know, if you take lime juice, it has a unique sour taste. Lime juice has a unique sour taste. Substances that carries out a unique sour taste is called as an acid. So this is an acid. So here acid is going to react with a base. So acid-base reactions are referred as neutralization reactions. These are referred as neutralization reactions. So my dear children, let's see whether the neutralization is given here as a response or not. Of course, in the second one, you can observe neutralization. So when you are going to react an acid with a base, both acidic and basic features disappear to form neutral substance. That's why it is called a neutralization reaction. Question number 24. An acidic substance, right? Acidic substance. Magnesium oxide, I told you in the earlier cases also, magnesium oxide is basic. Magnesium oxide is a basic substance. Second one, milk of magnesia. Milk of magnesia is also referred as magnesium hydroxide. Right? Magnesium hydroxide. Milk of magnesia also referred as magnesium hydroxide. So magnesium hydroxide, once again you can observe the hydroxide thing. So magnesium hydroxide is also a base. Next one, lime water. Lime water means calcium hydroxide solution. Calcium hydroxide. So this is also a base. This is also a base. As there is hydroxide thing at the end, I told you if there are hydroxide, then it definitely should be a base. So magnesium oxide, a basic substance. Milk of magnesia or magnesium hydroxide, that is also a basic substance. Lime water or calcium hydroxide is also a basic substance. So our answer would be definitely vinegar, right? Vinegar. Vinegar is our answer, right? So vinegar, you know that we use vinegar in making pickle. So pickle have a sour taste. Sour taste is given out due to vinegar. The acid contained in vinegar is called acetic acid. Acetic acid, right? In vinegar, the acid contained is referred as acetic acid. Acetic acid. So acetic acid is the substance or the acid contained in vinegar. Right. So let's move on with the next question. More heat is given during. More heat is given during. So more heat is produced or given during a complete combustion of a substance when there is plenty or adequate amount of oxygen, right? When there is adequate amount or plenty of oxygen present in the environment, substances are going to subject to a complete combustion. During a complete combustion, blue color flame is going to emit, giving out more amount of heat. So more heat is given during complete combustion of a substance. Complete combustion of a substance. Right. the color of methyl orange in basic medium. Color of methyl orange in basic medium. So this methyl orange, you have learned about methyl orange in grade 7 when we are discussing about acids and bases. So my dear children, methyl orange is a type of an indicator. Methyl orange is a type of an indicator that we use to identify acids like phenolphthalein, to identify bases. So to identify an acid, we use specially a substance called methyl orange to identify acids. Remember. So methyl orange usually in yellowish orange color. Okay, yellowish orange. It has a yellowish orange color, methyl orange. So with the presence of an acid, right? If there is an acid, okay, if there is an acid, then the color of methyl orange, right? The color of methyl orange is getting converted into a wonderful red color. You know that acid color is the red color. If you put a pH paper onto an acid, red related color could be observed. Red related color could be observed because red is the color that gives for an acid. Okay, so methyl orange, with the presence of an acid, it gives a wonderful red color. Okay, it is giving out a wonderful red color. It is getting changed into red color. This yellowish orange color is getting changed into red color with the presence of an acid. Okay, so with a base there is no change with the color. The color would remains the same in methyl orange with a reaction or with a base. If you add methyl orange to a base, there is no color change. Color of methyl orange would remains the same. It can give a color only with acids. With acids, methyl orange change into red color. So if you take methyl orange in here as an indicator, right, with the basic medium, it's going to produce, it's going to give out just a yellowish orange color. The color is not going to change at all. So the answer for this one would be yellowish orange. Yellowish orange is our answer. So remember children, methyl orange is in yellowish orange color. With the presence of an acid only, it turns to red color. With bases or any other neutral substances, it won't be able to give out different color. The color of the methyl orange, which is yellowish orange, would remains the same. Right then. From the reaction between sodium hydroxide and copper sulfate, from the reaction between sodium hydroxide and copper sulfate. So we did this experiment at our laboratory, and you could see that a blue color precipitate is given out during this reaction. Blue color precipitate is given out from this reaction. So my dear children, let's see whether the answer is given. Reddish precipitate is given. No, this is incorrect. Blue color is the one which is given out. Gas bubbles are given. No. Blue precipitate is given. Third response is the correct answer. Right? Blue precipitate is given out. That is our correct answer. Right. Question number 28. Metal that do not tarnish. You have to select the metal that is not going to tarnish. If it is not tarnishing, means that it should be very low reactive. Okay, it should be very low reactive. Very low reactive means actually here the strength or the combining ability of this metal with different substances is very less. Okay, physically it's going to behave, or physically it's going to act as a native element or native metal. So if it is not going to tarnish, then the luster of this substance, it's a metal, no, it should have a luster. So the luster of this metallic substance should last for a very long time if it is not going to tarnish. So my dear children, if the metal is not tarnishing, luster is going to keep for a very long time. So you know that if you take gold is a type of a metal that we use to make jewelries. Why do we make jewelries especially from gold? It's because that the glitterness of the jewelries, or the luster of the jewelries, right, is going to last for a very long time with gold. Right, with gold, luster is going to last for a very long time. So that's why we make specially jewelries with gold. So due to that nature, gold is very expensive also. Right, due to that lustrous nature, gold is very expensive. Other metals are also lustrous if you clean it very well. But the thing is that those metals are going to tarnish very quickly in the environment, and the luster would be reduced. So the metal that is not getting tarnished very quickly, metal that do not tarnish, in this question, the answer or the response, the correct one is gold, my dear children. Gold, if you take gold, luster of the gold is going to last for a very long time, as it is not going to tarnish very quickly. Gold is not going to combine with oxygen gas quickly, right? Actually, it is a very poor reactive metal, right? It's very poor reactive metal. Combining ability with oxygen or making an oxide layer, right? Making an oxide layer, ability of making an oxide layer in gold is very less. Okay, so the answer for this one would be gold. If you take copper, when time is going to pass by, I told you that a green color substance, a green color material is going to tarnish the copper surface. So that's copper oxide. Okay. Iron, you know that iron oxide is going to create. Magnesium. Magnesium is hugely, it's going to react very quickly with oxygen. If you take a fresh magnesium piece and leave it for a few hours, you could see that the tarnishing process or the reduction of luster is going to happen very quickly. Within hours, it's going to happen, right? So magnesium is a type of metal that tarnish very quickly, extremely quick, right? It's going to tarnish very, very quickly. If you take iron and compare it with the magnesium, magnesium has overtaken iron with several units, right? So magnesium is going to tarnish very quickly in the environment, even quicker than iron, right? It's because of the reactivity. Magnesium can bond with oxygen very quickly in the environment, right? So magnesium is more quicker. Among these metals, magnesium is the quickest one to tarnish. Okay, so the metal that do not tarnish is gold. Gold is our answer there. Then the next one. From the reaction between sodium hydroxide and hydrochloric acid. Here you are given with sodium hydroxide and hydrochloric acid. Once again you can observe hydroxide. Hydroxide means it is a base. Then hydrochloric acid and acid. So this is also an acid-base neutralization reaction. Right? Acid-base neutralization reaction. So let's see what are the responses given. Reddish precipitate is given. Wrong. Gas bubbles are given. Once again wrong. Gas bubbles are not going to occur. Blue precipitate is given. No, right? You can't observe a blue color precipitate in here. Then what should be our answer? Does the heat is going to change? Oh, when during this reaction heat is going to produce? Of course, right? During each and every neutralization reaction, some amount of heat energy is going to be produced. Some amount of heat energy is going to be produced. In simple, when you mix an acid with a base, the container is going to heat up somewhat due to production of heat by the reactants when they are converted into products. So my dear children, answer for this question is heat is given out, right? Heat is given. So by the reaction, remember, by the reaction between an acid and a base, always some amount of heat energy is given out, right? There is a temperature difference. There is a temperature increase in the system when you are reacting an acid with a base. So our correct answer for this response is heat is given. Right. Then the 30th question. See, the opposite of the previous one. I think you could remember the same responses is given here, right? I kept the same responses because you know that these metals, if you compare the ability of combining with oxygen, right? I told you that in magnesium it's very high. So let's come into the question and we'll select the answer. Metal that tarnish quickly, right? Opposite of the above one. Metal that is going to tarnish very quickly. The opposite of the previous question. So the metal which is going to tarnish very quickly should have an ability to attract with oxygen very quickly. So that metal is magnesium, right? That metal is magnesium, not iron. So earlier I told you that magnesium is going to overtake iron by miles, right? It's because that magnesium is very more reactive, far more reactive than iron. The strength of combining ability of magnesium with different other chemicals and other substances is very high for magnesium. But for iron, it's somewhat less. That's why to rust iron, few days is going to pass by. But if you take magnesium, magnesium is going to tarnish very quickly, like in hours, it's going to happen. So my dear children, the metal that is going to tarnish very quickly in the environment is magnesium, not iron. Okay, remember that thing. Okay, so we'll move on with the next question. pH range for a basic substance, right? pH range for a basic substance. So if it is a base, then the pH value should be greater than 7, right? pH value should be greater than 7. If it is exactly 7, then it is a neutral substance. If it is less than 7, then it is an acidic substance. 1 to 7 acidic, Exactly 7 neutral, 7 to greater than 7 is basic. So you have to select the correct answer from here. 6 to 7. So the pH value is less than 7. Means this is in acidic nature. Acidic or like we can say neutral acidic, neutrally related acidic nature. Okay. Next one. 7 to 8. Once again, neutrally related basic nature. Okay. It's more equal to neutral substance because pH value is between 7 to 8. So we can actually take these things as, I'll erase the acidic part. If you take both of these ranges, those things are much closer to 7. So therefore, nearly neutral. Both of these, right? Both of these ranges are nearly neutral. Nearly neutral means actually it is neutral, right? More closer to neutral. So therefore, we can't take these two answers. Then next one, 1 to 7. 1 to 7 is terribly acidic. Then final one, 7 to 14. Yes, this is the basic, right? This is the basic range for a this is the basic range in pH value for a basic substance, right? If you take a basic substance, the pH range is from 7 to 14 or greater than 14 also can be observed. So you can't take this 7 to 8 region because it is more nearly, because it is nearly equal to neutral level. So therefore it's wise to use this 7 to 14 region, right, as it is talking about a basic substance, right? 32. A combustible substance, right? So let's see the responses. Combustible means it should be able to react with the oxygen gas very quickly to produce heat and light energy. Okay, that's what do you mean by the combustion, right? So let's see. Combustible substance. Bricks. Bricks is not going to make with fire, right? It's not going to make fire. Bricks. Salt. Salt is also not going to burn. PVC pipes, right? When you heat PVC to extreme temperature, it's going to burn. But however, you have to select the most accurate answers in here, no? So PVC is also not a good response, right? It's not a good response. Then finally it is given hydrogen gas. Does hydrogen gas is going to combust? Or is it going to catch up with fire very quickly? As it is a combustible substance, right? It should be able to catch up with fire very quickly. Of course, my dear children, this is the answer. Once again, I told you that if we are going to eliminate the incorrect answers, the remaining one would be the correct one. So definitely hydrogen gas is the correct answer. If you take rocket fuel, right? Rocket fuel. In rocketry industry, we use special kind of a fuel to power up their engines. Rocket fuel is hydrogen gas, right? We use liquid hydrogen as rocket fuel. We use liquid hydrogen as rocket fuel. Okay, so in the next year, grade 9, there is a lesson called space exploration. So under that part, you'll be given with a session when we are going to discuss about that rocketry, right? The rocket fuel thing, the rocket fuel that we use in space explorations are hydrogen gas, right? So hydrogen gas is a good combustible substance. It's going to react with oxygen very fast. It's going to combust very fast, and to create, right, to create the relevant products. Usually when you are burning hydrogen gas, water vapor is the main product created, right? So hydrogen gas is a good combustible substance. So answer for this 32nd question would be hydrogen gas. That's the combustible substance. Name given for the state change from solid to liquid. Solid turning into a liquid. Solid turning into a liquid is called fusion or else melting. Fusion or melting, right? So select the correct answer that has fusion or melting. So deposition, incorrect. Fusion, that is our answer. Vaporization, incorrect once again. Evaporation, once again, incorrect, right? Evaporation is also incorrect. So the correct answer would be fusion. Fusion is the correct answer for the state change from a solid to liquid, right? Fusion or melting. Zinc metal is used in painting, galvanizing, rusting of iron, none of the above. So you know that zinc is a metal that we used in day-to-day life for the process of galvanizing, right? To galvanize ionic or metallic substances, iron substances, especially we use the metal called zinc. So zinc is used for galvanizing process. Galvanizing. Galvanizing is the answer. In galvanizing we use zinc. Right. When zinc metal is reacted with hydrochloric acid, the gas which emits. When zinc metal is reacted with hydrochloric acid, the gas which emits. So here you are given with a special kind of a reaction. We did this experiment at the laboratory also. So I told you that during this reaction, the gas which is going to emit is the hydrogen gas. This is how we prepare a sample of hydrogen gas at our laboratory, by the reaction between zinc with a particular acid. You can use any kind of an acid. No need to use hydrochloric acid, right? You can use sulfuric acid, you can use nitric acid. When you put zinc into any kind of an acid like this, the product created, or the gas bubble which is getting created, is hydrogen gas. So hydrogen gas is the product created during the reaction between zinc and the hydrochloric acid. Okay, so my dear children, answer for this response would be hydrogen gas, not oxygen, not nitrogen, not carbon dioxide. When you react a piece of zinc, right? When you react a piece of zinc with hydrochloric acid, the gas given out is called the hydrogen gas. So hydrogen gas is the substance which is getting created here. Right. Question number 36. Following experiment is used to test law of conservation of mass. Yes, we did this experiment at our laboratory, right? This is being conducted to observe the unique feature which is referred as the law of conservation of mass. So in a closed system, we studied that the total mass is preserved or conserved during a chemical reaction, right? In simple, after a chemical reaction and before the chemical reaction, if you measure the masses in a closed system, that mass is constant. It's not going to change at all. Okay, so here you are given with a figure. In this figure, you can observe two substances X and Y. So here it is given that following experiment is used to test law of conservation of mass. answer the questions 36 to 40 using it. Now we have to answer the questions from 36 to 40. Okay. So the substance X is substance X. X is the liquid which is at the conical flask. So you have to find out, or you have to write, underline what is that liquid. So let's see. Lead nitrate, magnesium oxide, sodium oxide, sodium nitrate. So the correct answer for this thing is the two chemicals that we use in here, or X chemical, in simply X chemical. The X chemical is lead nitrate, my dear children. Lead nitrate solution is the one that we use here. Lead nitrate. Okay. Lead nitrate is the solution. The X solution is lead nitrate. Right. Then the question number 37. This system is open, closed, open and closed, none of above. So if you take this system, you could remember we plug this cork into the conical flask, then we kept it airtight by pasting a layer of clay or else Vaseline or wax, right? So at the laboratory we applied a layer of clay on the cork after fixing this instrument or after fixing this setup. So my dear children, this is a wonderful closed system, right? This is a closed system. None of the particles can enter inside the conical flask, and the particles or the products which is created during the reaction between Y and X, when you mix these two substances together, cannot escape from the conical flask. So this conical flask, the system inside the conical flask is a good closed system. So my dear children, this is a closed system, right? It's a closed system, right? The solution Y which used here is the solution Y which is placed at the ignition tube. Let's see. Sodium hydroxide, sodium chloride, copper sulfate, sodium nitrate. So the substance that we used in Y solution as the Y solution is the sodium chloride solution, common salt solution, right? So sodium chloride is the correct answer. Sodium chloride solution is the Y solution, right? So question number 39. From the reaction of X and Y, right? From the reaction between X and Y. So when you mix sodium chloride solution with lead nitrate solution, what is going to happen? So we did this experiment at our laboratory, and you could observe that a white color precipitate is going to create. White color substance is going to create, right? So creation of a white color precipitate or creation of a white color powder is the observation for this experiment. So when we are conducting this experiment at our laboratory, you could observe this thing as well. So let's go for the responses and we'll see what are the responses. Gas bubbles are given out. No. White precipitate is given. Yes, this is our answer. White color precipitate is given out. Blue precipitate is given. That is also incorrect. Reddish substance is given. No, this is also incorrect. So the correct answer for this question would be, if you take this system, right, when you mix these two liquids together, lead nitrate and sodium chloride solution, right, the substance created or the product created is in white color. So and also it is a precipitate that's going to deposit it within the liquid, right? So the white color precipitate is given out. That would be our answer, right? Mass of the system before and after the mixing of X and Y is. So they are asking about the mass of this closed system before mixing X and Y and after mixing X and Y. In simple, before the chemical reaction and after the chemical reaction, right? So they are asking about the mass of this system before and after mixing these two substances together. So this is a closed system, my dear children. According to the law of conservation of mass, in a closed system, if a chemical reaction is going to occur, then in that case, the total mass is not changed at all. It's going to be preserved within the system, as new substances are not getting entered to the system, or else the new substances which is created are not exiting from the system. So therefore, if you take these systems, closed systems, in closed systems, my dear children, right, what happens? In closed systems, the total mass is preserved before and after a chemical reaction. Before a chemical reaction and after the chemical reaction, if you check the total mass would remain the same. Mass of the substance is a constant value. It's not going to change at all. So answer for this question would be mass is not going to change. Mass is equal or mass is constant. Let's see whether the responses are given or not. So mass of the system before and after mixing X, Y, right? Equal, not equal, mass increase, mass decrease. So our answer would be equal. Before and after the mixing of X and Y, mass would remain the same. It would not change. It would not increase. It would not decrease. It remains the same. So answer would be equal. Right. Question number 41. Blank is given, absorb water vapor from atmosphere. Right. So you have to fill out the blank by using the responses given here. Number 1 given, silica gel. Earlier we discussed that silica gel can absorb water vapor. So this is correct. Right, silica gel can absorb water vapor from the atmosphere, so this is correct. Number 2, calcium hydroxide. Calcium hydroxide can't absorb water vapor, but there is a certain substance that calcium hydroxide can absorb. Calcium hydroxide can absorb carbon dioxide gas. That's why the color of calcium hydroxide solution or lime water solution. Calcium hydroxide means, my dear children, lime water. So color of lime water solution is getting converted into milky white with the presence of carbon dioxide gas, because carbon dioxide gas is going to absorb into the calcium hydroxide solution when creating that milky white solution, right? So carbon dioxide is the substance that can be absorbed by calcium hydroxide. Okay. Next one, calcium chloride. This is also correct. Calcium chloride is also used to absorb water vapor. When we are doing that experiment about the tarnishing of metals, about the rusting of iron, we insert calcium chloride at our laboratory, right? So it's because by adding calcium chloride, you know that we can absorb, or we could eliminate the water vapor contained within that system. So calcium chloride can also be used to absorb water vapor in the atmosphere, right? So A and C are the correct responses. So both A and C are the answers. Right. Color of the flame given out when burning sulfur. We burned a piece of sulfur at the lab, and you could observe that the flame of the sulfur is blue in color. Sulfur is giving out a blue color flame when it is going to burn in air. Yellow color sulfur is going to produce a blue color flame, my dear children. So the flame given out by burning sulfur in air is blue in color. So our correct answer would be blue color, right? So bright white color is given by magnesium. Bright white is given by magnesium, right? We did this experiment at the lab as well. Bright white is given by magnesium. Bright yellow, this is given by a metal called sodium. Sodium is giving out a bright yellow color flame in street lamps that we use in highways, that has a bright yellow color flame, bright yellow color light. It's because of the sodium vapor that we used inside this. Sodium is a type of a metal that we use to get a bright yellow color flame. So however, it is asking about sulfur. So sulfur is giving out a blue color flame, right? Color of the flame in a complete combustion. Flame in a complete combustion. So if you take a complete combustion, there is adequate amount of oxygen gas and it's going to react with the combustible substance and going to produce a flame. So they're asking about the color of that flame. So if you take the Bunsen flame has a blue color. So blue color is coming due to the complete combustion of fuel. So during a complete combustion, right? During a complete combustion, the flame given out is in blue color, right? Blue color. All of these things, all of red color, yellow color, orange color, these colors are given out due to incomplete combustion, right? Due to incomplete combustion, all of these colors could be observed. If incomplete combustion is there, then you can observe different other particles, different other products like unburned carbon particles, carbon monoxide, soot, ash, and those things can be observed, right? It's due to incomplete combustion. During a complete combustion, the only products which are getting created are water vapor and carbon dioxide gas. So they are asking about the color of the flame. Color of the flame is blue in color during a complete combustion, right? Used to control the oxygen flow in a Bunsen burner. In a Bunsen burner, to control the oxygen flow, we use that collar, and that air pour is the one which is going to help to control the oxygen flow inside a Bunsen burner. So let's see our responses, my dear children. It's given. Number 1, foot, incorrect. That helps to keep the Bunsen burner rigid. Air pour. So this is our answer. Air pour is the one which is going to help to control the oxygen gas, right? To control the amount of oxygen gas. Next one, gas tube. No, that helps to flow gas into the system or into the Bunsen burner. It helps to flow gas into the system, the gas tube. Then finally, stem. Stem is also not, that's the part or that's the unit which helps to create that Bunsen burner, right? Stem. So that's the tube which the gas is going to come out at the end. Okay, so stem is also incorrect. The correct answer would be air pour, right? That's the one which is going to help to control the amount of oxygen gas in a Bunsen burner, right? In a flame of a candle and Bunsen burner, highest temperature observed in. Right. So, in a candle flame, right, highest temperature could be observed in barely visible zone or invisible zone. Even with the Bunsen flame, it is the same, right? At the barely visible zone or invisible zone, you can observe the highest temperature, right? So the correct answer would be invisible zone or barely visible zone. Right, so let's move on with the next question. Temperature at which a fuel start to burn is called. So the temperature which a fuel is going to start the burning process. So this temperature in which a combustible substance, right, the temperature which a combustible substance is going to start the burning process is called as the ignition temperature. It's called as the ignition temperature. So let's see. Yes, ignition point, ignition temperature. Melting point. So melting point is the temperature at which solid turns to liquid, right? Solid turning into liquid at the melting point. Boiling point. At the boiling point, liquid, right? Liquid is turning into gas. At the boiling point, liquid is turning into gas. Freezing point. Freezing point means the temperature at which a liquid turning into solid. Right? These are the explanations for the other responses. At the melting point, solid is getting converted into a liquid. Boiling point, liquid is getting converted into a gas. And at the freezing point, liquid is getting converted into a solid. Right? Okay. So our correct answer for the temperature at which a fuel starts to burn is called the ignition point. Right. Physical changes are. So physical changes are. So if you take a physical change, no new substances are going to create at all. Composition of the substance remains the same. Only the state can be changed, or only the state is getting changed from liquid to solid, solid to gas, gas to solid, gas to liquid. Like that way, state transition is going to occur. That's it. Okay. And the specialty is that in a physical change, if you take a physical change, physical changes can be reverted back to original position or the original state. So let's see what are the responses, my dear children. Physical changes are state changes. Correct. Reverse back to original state. That is also correct. Reverse back to original state. Third one, not giving new substances. That is also correct. Physical changes are not giving new substances and they can be reversed back to original state and they are simply state changes. So all of these responses are correct. So our answer would be above all. Then in a chemical change, new substances are created. Correct. In a chemical change, you know that apart from a physical change, a chemical change is going to give out new substances. Those are the ones which are called as products, right? So new substances are getting created from a chemical change. So that is okay. Sound may given out. That is also correct. Sound, heat, light, those kind of energy can be observed, and heat also, right? Sound, light, heat, that kind of a form of energy can be observed. So that is also correct. Okay, sound is given now. That is also correct. Next one, arrangement of particles may change. Arrangement of the particles may change. That is also correct, my dear children. It's because that by changing the arrangement, by changing the structure, by changing the atoms of the particles, by changing the order of the arrangement of the atoms, new substances are getting created, right? I think you could remember during the formation of magnesium oxide, I drew it and show that magnesium is like A, oxygen is like B. So magnesium oxide is like AB. So the arrangement is going to change in forming new substances. So this is also correct. So the correct answer would be above all. All of these things are correct. Right then. Best method to avoid rusting of iron. They are asking about the best method. So best method to avoid rusting of iron. Best method to avoid rusting of iron. We'll see the responses. Applying paint. Applying paint. Right? If you take application of paint, here we avoid the contact of oxygen with the metal surface and contact of water with the metal surface. So it's okay up to a certain level, right? But when the paint is going to scratch off, it's going to rust very quickly. So we have to protect the layer of paint plus the metal, right? So it's not a good method, right? It's not a good method. Time by time we have to, like after like 1 or 2 months, we have to repaint it. That paint is going to wear off some kind of a day. So we have to repaint it once again. So applying paint is not a good option to protect iron from rusting. Next one, applying oil or grease. That is also the same. Galvanizing. My dear children, galvanizing is the best method. We discussed this thing under the tarnishing of metals, right? Galvanizing is the best method to protect iron from rusting, right? So galvanizing is our answer, right? Most of you may confuse with this question, and you guys will go ahead for above all response in here. But they are asking about the best method, my dear children. Best method. So if they are asking about the best method, the correct response would be galvanizing. Right. 50th one. When blue litmus is added to A, there is no color change. When red litmus is added, it turns to blue. Nature of A. So here, blue getting converted to no color. Red is getting converted to blue color. So if red is getting converted to, right, blue color, my dear children. Blue means the color of base, right? If red is getting converted to blue color, right? If red is getting converted to blue color, we can say that this substance, right? This substance is a basic substance. So basic substance is our answer, right? By the reaction of or when you add a red litmus into a basic substance, color of red litmus turns to blue color, right? We did this experiment at our laboratory. We used sodium hydroxide and we observed that red litmus is going to turn into blue color with the presence of this, right? With the presence of this red litmus, or when you add red litmus to a solution, right? What kind of solution? A basic solution. Red litmus is getting converted to blue color. We observed that thing. We did this experiment at our laboratory. So my dear children, red litmus is getting converted to blue color with the presence of base, right? But the blue litmus is remained the same color as the base color is blue, right? So we discuss several MCQ questions in this part. So we'll discuss several other types of questions, essay type questions in our next chapter.